auditors, now we are at Ethernaut Elevator Challenge. You can see that this is the smart contract, and in order to solve this challenge, basically we have to change our top and our floor. So basically our top equals to true and the floor is basically whatever floor we want. And over here there's only one function here. So now we'll move on to Visual Studio Code, where basically I just copy the codes from Ethernaut to Visual Studio Code. So I'll explain how this works. It's actually quite simple. So we have this particular interface building, and we have this contract elevator, and there's two state variables, top and floor, and this one function, and you can see that this is initialized by the sender or the caller. And basically what this does is that this particular contract uses this interface so that it can interact with whatever contract they were using. And since this is the attacker contract, it will just be known as attacker contract. And over here, since we have this particular malicious contracts to interact with this function, we can sort of play with how we want to ensure that we pass this if-else statement. So as I was saying, over here, once it's initialized by the caller, and then we have this particular interface or the function that is actually from our attacker function. I'm going to explain what this attacker contract does. You can see that this is just a normal contract, and we have a boolean equals to true, and then we have our particular target variable and our constructor that initializes the target. And over here, this function is last floor. So what this function does is that it will take the boolean and convert it to the opposite of the truth value of a boolean expression. So since our boolean is true in the first place, it will be converted to negative, and then so on and so forth. So over here we got this simple illustration. So if boolean equals true, boolean will become false, else if boolean is false, you'll convert back to true. So this is how it works. So in order to solve this particular challenge, you just have to call this function. So what this particular function does is that you will just call this, which will interact with the interface, and then call this particular function. So let me further explain like how this if-else statement works. It's actually quite simple. So basically over here we got the not logic operator. So what this particular if-else statement wants is that in the first place it wants to be false, and since this is converted to be false and return false, this if-else statement will be passed through, and it will set the floor to whatever variable that we have inputted in the first place to whatever floor we want. So for example, over here we have set 1, so this will be the first or the first floor. If you actually is quite contradicting, maybe I should change to second floor, but whatever, let's just put 1 here, because in boolean 0 is false and 1 is true. But anyways, let's move on. Top equals building dot is last floor. So what this means is that now, and previously it was basically false. Now we have to basically call the function again, which will turn false to positive, and thus making this function true. And this will change our particular state variable to top to true and floor to 1. So we can check our particular Brownie script over here. You can see that in order to solve this challenge, it's basically quite simple. You just get the contract instance over here, just paste it here, and then you can just deploy and call the attacker function. And let's just wait for the Brownie script to run. Okay, now the Brownie script has run successfully. You can see that particularly this attack function has been called, and let's just check. So very simple, await contract.top. You can see that we have settled it. Top equals true, and the floor we set is 1. Yep, it's over here. So let's just submit the instance, and we should be able to complete this challenge. Okay, you can see that we have successfully completed this challenge. Now let's dive into the vulnerability. So what this particular vulnerability is that the attacker is able to utilize this external function. So if you do not want any attacker or anybody else users to use this particular contract that have this interface interacting with this particular smart contract, we have to just change this to view, that only allow any other contracts such as this to just view these particular functions, or you can just set pure. They are pretty much similar. So there's one way to solve this vulnerability, by only allowing certain function to be external. If you guys like this tutorial, please hit the subscribe button, and thank you for watching.